Hey guys, welcome to this video. So in this video we're going to solve this problem. I'm going to explain this problem in a bit. So basically this is one of the problems that is in the tomato book. This is one of the subjectives and it's a very interesting one. So in this video the key objectives for you to take away would be how to do angle chasing inside a circle and how to apply the cosine and the sine rules. That is basically how to apply trigonometry effectively to find this question. So it's a pretty hard one, I would say. You are given a circle with radius r and you have to prove the area inside this star is basically this 10 r square tan of pi by 10 divided by 3 minus tan square of pi by 10. And given that this is a regular pentagonal star, when I say regular, it means that this arms AP, BP, BQ, QC, all these are equal in length, and that it is obviously symmetric, and these are single straight lines. Like AD is a single straight line, you just don't have the portion between them. So that is how pentagonal regular star is drawn. So let's begin. I'm going to work with only a specific portion of the figure because we do not need to work with the whole figure because it is symmetric in nature. So first of all, you can understand that if you join OA and OB here, this angle that you get in the center, this is going to be exactly 1/5 of the whole angle that this point has around it, because you can do the same for OE, OD, OC, and you will get 5 such sectors, right? Because it is divided into 5 different sectors. That is why this angle, the angle around a whole point is 2 pi. So this angle AOB should be equals to 2 pi by 5, correct? Also, since this is 2 pi by 5, if you see carefully this, and also we can join AB here. So AB is joined. We do not know the length of AB, but that's okay. Now, if you carefully see, AD and BD are basically, do not go on the drawing, it should be a same line basically. So when you actually draw this B and D, they would be coinciding on the same line, they would be congruent. So this AD and BD are basically the same lines that originate from A and B, and you also see that angle AOB is basically the angle at the center, while angle ADB will be the angle at the circumference, which means angle at the circumference should be half of what is angle at the center is. So if angle at the center is 2 pi by 5, as I said, this angle should be pi by 5. Similarly, each of these angles should be pi by 5 by symmetry. You can do the same exercise in any one of them, right? Now we got that. Again, since OA is the radius and this whole figure is symmetric, right? And OA is cutting this angle in half, and also AP and AR are also equal. So this must also cut this angle in half because of the symmetry. So this angle here, let's name it PAO, right? Angle PAO is also equal to half of this whole angle PAR, all of which angles are pi by 5. So you get that this angle and this angle, both of this are half of pi by 5, which add up to make a pi by 5. So this should be pi by 10, correct? Now, first things first, in the triangle OAB, if you consider the triangle OAB, you can see that we know that OA and OB are equals to R because these are the radius, correct? And you know this angle. So we can find the other side AB. How can we find it? We can find it using the cosine rule. So apply cos of 2 pi, right? So cos of 2 pi by 5, and you know that cos of theta would be equals to AO square plus OB square minus AB square divided by 2 times OA into OB by the cosine law. So this should be equals to 2r square minus, let's say AB is AB, so let it be AB square divided by 2 into r into r, which is 2r square. If you simplify this, you will get AB equals to 2r sine of pi by 5. That is going to be a value for AB. You will have to apply the multiple angle formula as well. Okay, that much we got. From this information, we can easily find the area of AOB as well, because the area of AOB should be half into OA into OB into the sine of the included angle. That is one of the formulas you have learned in properties of triangles. So half into r square into sine of 2 pi by 5. This is going to be your area. This is going to be your area of the triangle AOB with this angle. Now we do not need this whole area. We need to subtract the area of APB from this, correct? Now this angle is pi by 10, correct? Similarly, this angle is also pi by 10. And you see that OAPB is a quadrilateral. The sum of the angles in a quadrilateral is basically 360 degree, which is 2 pi. So if this angle is alpha, this angle should be 2 pi minus alpha, correct? Because angle around this point P is also 360 degrees, and we need this angle APB. So if we need this angle APB, because then we can obviously find the area of the triangle APB, which we have to subtract from the area of AOB to get this region, and then we basically have to multiply it 5 times to get the answer, correct? So how do we do that? Okay, so what we can do here is this. We can see that the sum of these 4 angles is 360 degree, which means 2 pi by 5 plus pi by 10 plus pi by 10, which is pi by 5, plus this alpha should be equals to 2 pi, correct? Now if you do this, this is 3 pi by 5 and you have to subtract 3 pi by 5 from this 2 pi. So you basically have this, but what we basically need is 2 pi minus alpha, as I said here, because that is the value of the angle APB. So basically angle APB equals to 2 pi minus alpha equals to, okay, so AP equals to BP equals to T, and again in this triangle we would like to apply the same rules. So we know this angle, we know AP and BP, what are they, and we know the length of AD. What we can do is we can apply the cosine rule again on the angle APB inside the triangle APB. So cosine of angle APB should be equals to AP square plus BP square, which we have assumed as T, so 2T square, minus AB square, which is this 4R square, divided by 2 into T into T. Correct. This would give you, I think, 2T square into 2 sine square 3 pi by 10 equals to 4R square 5, or in other words T should be equals to R sine pi by 5 divided by sine 3 pi by 10. So this is the value of T. Now once you got the value of T, the area of triangle APB is equal, because you can see that APB is equals to half into T square into sine of 3 pi by 5. So your area basically becomes A equals to 5 times the area of the triangle AOB minus APB. So AOB was this, half R square into sine of 2 pi by 5 minus APB is this, half into T is this, R sine of pi by 5 by sine of 3 pi by 10, 3 pi by 10 whole square, I think, into sine of 3 pi by 5. Okay, you get the idea. It's a bit messy, but okay, this is your final answer, and this would be equal to this. Once you do the simplifications by transforming everything to tan of pi by 10, you would see that this is the correct answer. So that is how we do it. So I hope you liked the video. Let me know in the comment section whether you like this geometry problem or not.